Today's presentation will cover the low-flow isoflurane anesthesia delivery options available for mice and rats. Generally, anesthesia introduces confounding factors and variables that may affect your research outcomes. In today's presentation, we will talk about improving these variables, how inhalant anesthesia differs from injectable anesthesia, the limitations of traditional high-flow vaporizers, a low-flow vaporizer alternative, protecting yourself from waste gas exposure, and the role that physiological monitoring can have in your research outcomes. Precise anesthesia delivery in conjunction with physiological monitoring can reduce confounding factors and variables in most surgical procedures, helping researchers obtain optimal research results. The most common forms of anesthesia include injectable and inhalant. Injectable anesthesia is a liquid agent that is delivered intravenously or intramuscularly. Inhalant anesthesia is a precisely formulated liquid agent that is vaporized and delivered via inhalation. Injectable anesthesia is commonly used in laboratories worldwide. Its advantages include several routes of administration, no special equipment requirements, is often quick-acting and easily administered. There are, however, several disadvantages to the use of injectable anesthetics. They often have a significant physiological impact, require long recovery times, with dosage variations between strain and gender. Inhalant anesthesia is a much safer anesthetic option. The physiological impact is greatly reduced, and recovery occurs almost immediately. Consistency of anesthetic depth across strain and gender is also easily controlled. The most commonly associated disadvantage to inhalant anesthesia are the high equipment entry cost, scavenging access, and annual calibration. There are two methods of inhalant anesthesia delivery: a traditional wick-style vaporizer, also known as high flow, or a syringe-driven digital vaporizer, or low flow. Traditional wick-style vaporizers require high flow rates with a minimum of 500 mL per minute. Flow rate calculations are based on animal weight, resulting in the system's inability to deliver the calculated flow rate for very small animals. The SomnoSuite's digital vaporizer is specifically designed for animals utilizing room air or compressed gas, requiring no annual calibration and producing almost undetectable amounts of waste anesthetic gas. Isoflurane usage for a 30-gram mouse can be as low as 0.5 mL per hour. The SomnoSuite has the ability to deliver airflow rates as low as 25 mL or as high as 1,000 mL per minute. Calculations for airflow needs are based on body weight and are automatically generated. An internal pump removes the need for an external compressed gas source. With very few moving parts, it's easily maintained and requires no annual calibration. The SomnoSuite is safer for you and safer for your animal. When we compare the physiological effects of inhalant anesthesia and injectable anesthesia, the impact can be quite significant. With varying percentages of isoflurane, we see an impact of 20 to 30% on an animal's heart rate. This percentage, however, is significantly increased when injectable anesthetics are used. Ketamine and xylazine, for example, can lower an animal's heart rate by 55%. Our low-flow anesthesia digital SomnoSuite provides a more practical approach to inhalant anesthetic delivery. The SomnoSuite has flow rates as low as 25 mL per minute. It's compatible with multiple anesthetics, requires no annual calibration, and uses on average 0.3 mL per hour of isoflurane for a 30-gram mouse. There is no need for external compressed gas source because the SomnoSuite has an internal pump that utilizes room air.
Low-flow syringe-driven vaporizers are capable of flow rates as low as 10 milliliters per minute while delivering accurate anesthetic concentrations. Thus, this technique will be beneficial to groups performing rodent anesthesia due to improved safety, efficacy, and precision over traditional systems.
The intuitive touchscreen and the digital vaporizer auto-calculates the flow rate based on the animal's body weight. Induction chamber flush feature minimizes exposure to waste anesthetic gas. The SomnoSuite setup is very easy. The system pulls in room air, compressing it internally. Airflow is directed through inspiratory and expiratory ports on the top of the machine. Isoflurane is syringe-driven into the digital vaporizer, allowing for precise delivery to your animal's anesthesia mask, stereotactic stand, or induction chamber. All of the SomnoSuite's tubing is easily identifiable with color-coded tabs and connections. making setup a breeze. Black connection ports indicate expiratory lines and tubing, while white connection ports indicate inspiratory lines and tubing. Anesthetic delivery is easily adjusted by turning the large black dial. Isoflurane is delivered in precise percentages. The amount of anesthetic being delivered to the animal, along with the remaining amount of isoflurane in the syringe, is displayed on the system's digital touchscreen. The Somno Suite has several induction chamber sizes to choose from, ranging from 1/2 liter to 3 liters for larger rodents. Variation in induction chamber size, along with the system chamber flush feature, minimizes users' exposure to waste gas. Our low-profile anesthesia masks prevent exposure by creating a tight seal, ensuring that anesthesia is delivered to your animals to maintain an optimal plane of anesthesia. The usage of isoflurane is significantly decreased when compared to a traditional high-flow vaporizer. The Somno Suite utilizes, on average, 1 ml of isoflurane during a 2-hour time period. A traditional high-flow vaporizer will utilize 15 mLs of isoflurane in the same amount of time. Because of our tight-fitting, low-profile anesthesia masks and the low airflow requirements of the Somno Suite, the exposure of waste anesthetic gas is almost untraceable when compared to a traditional vaporizer. We've already discussed how beneficial the Somno Suite can be to your laboratory and the potential impact it can have on your experimental outcomes. Now we can discuss the potential cost savings that can be obtained by adding this to your laboratory. The Somno Suite system uses about 2.4 liters of isoflurane per year, while a traditional vaporizer will utilize around 24 liters of isoflurane per year. Factoring in no annual calibration and no oxygen, a high-volume laboratory could save up to $16,000 annually. The Somno Suite is easily customizable. Additional features such as warming, ventilation, SpO2, and CO2 monitoring can be added at any point, and these added features do not change the system's footprint. The Physiological Monitoring PhysioSuite is an alternative for laboratories utilizing injectable anesthesia. Its modular capabilities include warming, ventilation, SpO2, and CO2 monitoring. The right temp modules use far infrared warming with automatic feedback control for optimal body temperature regulation. The MouseStat module is a heart rate and pulse oximetry monitoring feature. With several sensors available for both mice and rats, it gives you the ability to obtain oxygen saturation values and heart rate, readily displayed on your system's digital touchscreen. The Rovent is a fully automatic ventilation system. It can be used in a volume or pressure control modes and can safely ventilate animals as small as 3 grams or as large as 1,250 grams. The Capnoscan is an end-tidal CO2 monitoring device. Its highly sensitive IR spectroscopy sensors allow for very low sampling rates. Values are easily displayed on your system's digital touchscreen. Kent Scientific also manufactures several other monitoring devices in addition to the Somno and Physio suites. Our non-invasive blood pressure monitoring allows you to monitor one animal's blood pressure while under anesthesia or awake using a tail cuff system. In addition to our single-channel blood pressure device, we also have a high-throughput CODA non-invasive blood pressure monitoring system, allowing user to obtain the blood pressure of 2 or as high as 8 animals on one controller. Systems can be linked together to measure a total of 48 animals during one experimental session. The CODA device includes a warming platform, digital software for data collection. We offer a line of warming products with different types of controllers. All infrared with homeothermic options, ergonomically designed sensors, and very small footprints to maintain laboratory space. We hope that you'll choose our products to maintain the best physiological parameters, ensuring great experimental outcomes. For more information, please visit our website at kentscientific.com.